my own original work. However, there is only a handful of copies. Only a handful of copies were made. For example, there is one signed and dated in 15th October 1965, which contains a typed dedication to Denise Sciamma, an influential physicist in his own right. All copies contained handwritten equations because typewriters couldn't manage mathematical formulae, so these had to be added later, probably by his wife Jane. Additionally, inside some copies, such as the ones that can be inspected online, one gets a rare glimpse of Hawking's handwriting, a note scribbled in pencil leads. This dissertation is my original work, S.W. Hawking. The year after he began the thesis, Hawking was diagnosed with a motor neuron disease that doctors predicted would kill him within a few years. There was a chance that he might never finish it. Nevertheless, he was determined to continue with his doctorate, partly so that he could get a job afterwards to support Jane. In his first 2 years as a postgraduate student, Hawking investigated several worthwhile topics and demonstrated that he was a promising talent, says Vermelho. His research only took off in his final year, however, when he heard about an exciting new discovery by the well-established mathematical physicist Roger Penrose. It had a brilliant insight. Penrose had proved mathematically that Einstein's theory of gravity predicts that sufficiently heavy stars must collapse into a cosmic object, later dubbed as a black hole, that contains a singularity. When Penrose set out his discovery as a seminar in King's College, London, in January 1965, Hawking heard about it from Brandon Carter, a Cambridge colleague who had attended. Then Sciamma made a point of bringing them together, and as Penrose recalled, it did not take Hawking long to find a way to use his theorem unexpectedly. They got on well, became friends, and later collaborated on classic papers about the mathematical singularities and Einstein's theory of gravity, says Vermelho, singularity theorist. Hawking applied Penrose's ingenious technique to the entire universe. This application of Penrose's ideas to the universe attracted the attention of leading theorists, many of whom recognized Hawking's potential, explains Graham Vermelho. He was soon widely recognized as one of the leading young gravity theorists to stand on the shoulders of Penrose, and later established himself as a singularly gifted theorist in his own right. Together, Penrose and Hawking showed that Einstein's general theory of relativity predicts that the existence of singularities in the birth of the universe or black holes. A singularity is the point where gravity becomes infinite and space-time. The union of time and space used in relativity simply ends. As the presence of such infinities in these singularities suggests, in such extreme situations, the laws of physics themselves break down. And Penrose Hawking hinted at a deeper physics was required. The physics of black holes. Hawking would become the preeminent expert on the physics of black holes. Cygnus 6X1, a galactic X-ray source discovered in 1964 in the constellation Cygnus, visible in the northern hemisphere summertime sky, was the first cosmic object believed to be a black hole, and became the subject of a famous bet between Stephen Hawking and his collaborator and future Nobel Prize winner Kip Thorne. As Hawking put it in his book, A Brief History of Time, he bet against the existence of black holes in the region as an insurance policy. I've done a lot of work on black holes, he wrote, and it would all be wasted if it turned out that black holes do not exist. But in that case, I would have the consolation of winning my bet, which would win me 4 years of the magazine Private Eye. In his own book, Black Holes and Time Warps, Thorne described how in 1990, Hawking eventually admitted he had lost the bet by breaking into Thorne's office late one night with his entourage, while Thorne was in Russia, finding the framed bet and leaving a note that conceded, signed with his thumbprint. Decades later, in the spring of 2019, astronomers unveiled the first image of a black hole, M87, at the center of the Virgo galaxy, a behemoth with a mass 6.5 billion times that of the Sun. located 54 million light years away from Earth. The feat was announced by a global research team of 300 researchers from 80 institutes, known as the Event Horizon Telescope Collaboration, which used observations from a worldwide network of radio telescopes. Although we cannot see the black hole itself, the image shows a telltale signature, a dark central region called a shadow, surrounded by a bright, ring-like structure. The new view captured light bent by the vast gravitational tug of the black hole at our galaxy's heart, which is 4 million times more massive than our own sun. In the wake of this proof of the existence of black holes, Roger Penrose, now at the University of Oxford, was awarded the 2020 Nobel Prize for Physics for the discovery that black hole formation is a robust prediction of the general theory of relativity. He shared it with Reinhard Genzel of the Max Planck Institute for Extraterrestrial Physics in Garching, Germany, and the University of California, Berkeley, and Andrea Ghez of the University of California in Los Angeles for their discovery of the supermassive compact object at the center of our galaxy. The only known explanation for this object was that it was indeed a black hole. If only Hawking had been alive, he might have shared the prize with Penrose. Hawking longed to win the Nobel Prize for Physics and rarely missed an opportunity to say so, says Graham Farmelo. Despite several nominations, the prize eluded him. The theory is that the Nobel authorities, slow to recognize progress in the gravity theory, did not award their prize for these exotic objects until the astronomers confirmed their existence, beyond all reasonable doubt. When Penrose deservedly won the prize for his seminal work on understanding black holes, Hawking had been dead for 2.5 years and was therefore ineligible for the award. His much trumpeted ambition was, sadly, unfulfilled. Above, X-ray telescope image of the binary star system known as Cygnus X1, a black hole candidate. Above, Stephen and Jane Hawking's wedding photo from the cover of Blanco Negro magazine, 22nd April 1989, which featured an interview and article on Stephen Hawking, Un genio en la intimidad, a genius in privacy. See also, Hawking Radiation, page 46, Stephen Hawking, You Are Wrong, page 176. Above, Trinity Hall College, Cambridge. Hawking studied a PhD in cosmology at Trinity Hall between 1962 and 1965.